Alright, so in this video I want to show you how to do the specific gravity test. Specific gravity of soil is just the unit weight of the solid particles of the soils with respect to the unit weight of water. So basically the ratio of the gamma of solid particles over gamma of water. Typically that value is something between 2.6 and 2.8, and a lot of times engineers just assume a value, but there is a procedure to do the test and actually come up with the GS of the soil. GS helps us in a lot of phase relationships and to calculate various different quantities of the soil, such as the unit weight. Essentially, to get the GS, what we need to do is divide the mass of the solid particles over the volume of the solid particles. The trick with this is the volume part, because mass is easy. We can just use a scale to measure the mass of the solid particles, but it's really difficult to measure the volume of solid particles of soil. Why? For two reasons, mainly because first of all, the solid particles of soils do not have shapes that we can calculate volume for, and second, there are many particles, and it's really hard to define the volume or a volume relationship to measure the volume of the soil. So what we do is measure the volume of soil indirectly by adding it to water and measuring the difference in the volume. Now, one little issue that is caused by doing that is when soil is added to water, it also adds air to the mixture. And what we need to do is to remove all of the air to get a correct measurement of just the solid particles of the soil. So in the rest of the video, I'll show you how to do that. What we need for this is about 100 grams of oven-dried soil, which I have in this little bowl. I need a thermometer to measure the temperature of my water and soil-water mixture. I need deionized water or distilled water. And the main tool that I'll need is a pycnometer, which I'm showing right now in this close-up right there. So this is called a pycnometer that I'll be using. In order to measure the volume of soil, I need to first calibrate my pycnometer. I need to calibrate it for various different temperatures of water. And you'll see in a minute why that's important. But to give you some idea, I'll be needing to boil the soil-water mixture, as I mentioned earlier, to get rid of the air bubbles. And therefore, I will have a mixture that'll be at various different temperatures. So I need to first calibrate the pycnometer at a range of different temperatures of water, say between 20 and 30 degrees Celsius. Then add the soil, boil the mixture, and go through the rest of the procedures to be able to come up with the GS. Alright, so the first step is to add water to the pycnometer to the indication level. And I have some deionized water in this bottle that I will be pouring into the pycnometer up to the level that I need to. Okay. I'll also get rid of the excess amount. Oops. Alright, so the rest, if I need to dry it out, I'll use a little bit of paper towel And with a little wire like this, I'll try to dry out the sides of the pictometer and absorb some water to bring it to the level I want it to. Since you're measuring the mass, and the mass of this is really important for the calibration purpose, you also want to have anything on top of the calibration mark to be dry. So right now I'm seeing that the bottom of the meniscus is right at the bottom of that line. So all I need to do here is to make sure that the sides above the line are dry. I'm just going to dry out anything here on the sides. Make sure there's no wet surfaces. There we go. So the next step is to record the mass of the pictometer combined with the water at room temperature that I have it right now, and mark that as 1 point. So the next step will be to grab the thermometer from the top and place it into the pictometer and measure the temperature of water. And then I'll do that at the bottom, at the middle, and at the top, just as a rule of thumb, so that I make sure that the temperature is all the same and consistent at various different points. So right now I'm getting right about 24 degrees Celsius, and it's pretty stable. So at 24, I bring it out, and then I need to measure the mass of the pictometer and water together. So I'll use the scale. Right now I have 667 grams. I'll mark that down. So the next step is, let me just actually show you that the water level is right at that calibration mark. The next step is to raise the temperature of the water, and as a result of that, we'll need to remove some of the water, because as water goes up in temperature, then it will rise up, and in order to keep it at that same calibration mark, I'll need to remove some water and then reweigh the total of the pictometer and water bottle and water together, right? So I'm gonna wait for the temperature to rise a couple of degrees. I don't want to go above 4 to 5 degrees Celsius of increase. So let's see if we actually went over or not. Doesn't look like we have, so we'll let this sit for another bit. We'll maybe go up to, so was it 24 degrees? Maybe we'll go to 28 degrees and then 32 degrees and record the weight of the pictometer and water. That'll help us calibrate the pictometer. So I'm going to measure the temperature one more time. Yeah, the temperature is about 28 now. So what I'll need to do is, first of all, make sure to use gloves when you're dealing with a heating source. So I'll take it off so that the temperature doesn't go up anymore. Then try to remove some of the water that's on the side here, on the side above the meniscus. And I can see that the water level has gone up the meniscus, so I'll try to absorb some of that with this paper towel. And dry up the surface above the line and reweigh it. Maybe grab a little bit more. Alright. That's good, and it's good for another measure. So as I measure it this time, I'm getting a mass of about 665.8. So a little bit of a decrease in the weight. So I'm going to place it back on here. Let the temperature go up a little bit more. And then redo this process whenever the temperature goes up another 4 degrees Celsius. That way I'll be finished with calibrating the pycnometer. Alright, now that I have my pycnometer calibrated, I want to test the soil now. So I fill up the calibrated pycnometer halfway with distilled or deionized water, and then I'm going to add the soil using a funnel. To the water. And when I do that, I'm going to make sure that everything is well mixed, and then I am going to raise up the temperature of the heating source and start boiling the soil. Okay. It's going to take a while, but it's going to start boiling. Alright, now that we've boiled the mixture for 10 minutes, we can take it off and remove it from the heat source. Make sure to wear gloves during this step because everything is very, very hot. So what I'll do next is I'll use a bowl of water to basically cool down the mixture that I have right here. The idea is to now bring back the temperature of the soil water mixture to the range of temperatures that I had calibrated the pycnometer with water. So I'm going to place it in here and let it cool down. And I'm going to periodically monitor the temperature of the mixture, and once it gets closer to about 32 degrees or 30 degrees where I had calibrated my pycnometer, I'm going to start adding water to the system so that the mixture and watermark comes back up to the calibration mark. And once I have that, then I'm going to record the weight, and I'm also going to record the temperature of the mixture when I weigh it. Now that a few minutes have gone by, I'm going to start drying out the sides of the glass, since there was some steam stuck to the sides. Take that off first. Give it a little shake here. Then I'm going to start adding water. So now basically I have the soil water mixture at the calibration mark. Gonna one more time dry off the sides here. So now that this is cooled off, this is our final product. And what I would want to do now is to measure the mass of this mixture and then record the temperature. And basically I've gathered all the measured data that I need to calculate the specific gravity.